Hello friends, my name is Nikhil Gaba and I'm part of the Customer Success Architecture team in MuleSoft. Today we'll talk about how to implement or realize chargeback model in MuleSoft. So chargeback model is about how different teams and groups within a company or enterprise know about consumption and the cost for the platform based on how much they have used, or it could be a different model. So with that context, let's dive in how we can realize chargeback in MuleSoft platform. As you might have seen or experienced, most of enterprise are embarking digital transformation programs like launching new mobile apps, transforming customer experience, or launching e-commerce presence for their customers. These initiatives are led by different teams who wants to build or use existing digital platforms like MuleSoft. Most of these teams might have budget and funding based on their programs, which is OpEx based and have tight business value proposition. Leaders for the respective team wants to know the usage of platform so they can model in their operations cost rather than just paying flat cost for creating and consuming platform services. As you can see in this visual, platform consumers wants to know the cost of using the platform, while platform owners on the other side wants to provide transparent consumption and cost for usage of platform to promote reuse. So to realize this chargeback model in MuleSoft, we have taken a use case our prototype is built upon. You can see there is a mobile team and an e-commerce team who have built an experience API and reusing existing system API for placing, updating, or deleting orders in backend order management system. They are the exclusive users of Experience API, but they are interested in opening up the system API to help distribute the cost that they incur to host the application and bring down the cost per request down a bit. So you can see in the visual, mobile team wants to understand what they are being charged for, and so as e-commerce team for a common system API. The chargeback models range in accuracy and complexity. We have found that providers often overrotate to high degrees of accuracy out of the gate instead of taking a more simple approach and arsing to precision over time. For the remainder of today's time, we will show you why this approach works and how to stand up in your organization. For our demo, we will use measured resource usage or calling party pays model, and I will show in the demo how it works and how we realize this chargeback. In our prototype, following API-led approach, we have built experience APIs for mobile and e-commerce, which are in turn calling a common system API to update CRUD operations on order resource. In our prototype app, we have used the Mule4 correlation ID, which trickles down or being passed from experience to system layer in our prototype. This correlation ID is logged with standard JSON logger to the Splunk. An out-of-box platform API can pull the full set of application and core configurations to compute the bills. As calling teams and groups call these APIs, our Splunk dashboards then break down the log in few ways. The first visual on the left is a breakup of requests for each app by the calling party. We use this data to determine the percentage of requests within an app that come from each group. For example, you can see e-com request for order SAPI is around 62.5%. On the right side of visual, we can also pull the core allocations for each app, so we have a way to translate the app request into dollars via cost per core model. We have decided to use a weighted cost per core to reflect the total reservation cost, given that most customers have a little headroom in their subscription to allow for bursts of activity. For example, you can see computed weighted core cost for order SAPI is 1.7. With the previous metrics of percentage app distribution and weighted cost per core, we can then show the dollar cost for each application broken down by the calling party. We multiply the request usage percentage by the weighted core usage and then again by the cost per core, and voila, you can see the cost of each app distribution by the client or calling party. We now have the information required to generate a bill for each consuming group, along with the exact information to show a creating team how much money they have saved by opening up their API for others. Once all the numbers are in place, making a bill is straightforward. And you just have to decide how often to send bills and decide if you want to go with the actuals by the month or some form of standard monthly rate with a true up, true down accounting on a quarterly cadence with your consuming teams. For example, you can see in this visual is a quarterly bill for clients, and you can see eCom API usage and mobile API usage bill for Q4 2020. So how do we piece all of this together? We have made all the components freely available in a GitHub repository called MuleSoft-Chargeback, and we are happy to help you get started in your chargeback and reuse journey. I'll briefly show the demo of this prototype as a next step, and in parallel walk through step-by-step process documented in GitHub how to execute this prototype in your environment. With that, let's move on to the demo. So once you log into the GitHub repository, which is MuleSoft-consulting/MuleSoft-chargeback, you can see the three main folders, config, images, and source. And you can also see the README file, which goes step by step on how you can implement this prototype in your machine, which we are anyways going to do it right now. So I will not go through this README file step by step, but you can keep that as a reference point if you are stuck anywhere while implementing this prototype. So the step one, what you have to do is download the code here, and you can download the zip file. Once you download the zip file, you can see the three folders in your machine: config, images, and source. The source contains all the three apps, which is e-commerce eAPI, mobile order eAPI, and then order SAPI. So basically 2 experience APIs we have created for eCom and mobile, and 1 system API, which is called or invoked by these experience APIs. And you can see the 3 configuration files in config folder. The images are nothing but reference to the images which are being used in the README file of snapshots, which I'm going to show anyways. So once you're done with downloading these source files, what you can do is open Anypoint Studio, and you can import these jar files. So click on File Import, and you can go to Package Mule Application Jar Files, click Next. Go to the location where you have downloaded this source files, which is the 3 jar files, and you can import all of these one by one in your Anypoint Studio. So once you're done with that, you can see the 3 apps running or opened basically in your Anypoint Studio, and you can run these apps by going right-clicking and run as, run configurations, and select all 3 and click run. Now I'm not going to do it, all of these are already running, but you can run the applications in Anypoint Studio. So the README file also talks about the configuration we have used in these apps. So what we have done is use socket appender to send the data to the Splunk, which is listening on 8787 port, and also used HTTP. Now in your application, you can use either of that, but we have given both the configuration for your reference here. The other configuration which shows on the README file is make sure that we have JSON logger application properties configured. And these are required because it also sends the metadata along with the project name and the app name, which is needed to correlate the data in Splunk. So once you are done with that step, the next step is to download the Splunk and run in your local machine, which is basically going to this site, dev.splunk.com. You can download the Splunk Enterprise version, which is a trial license, and you can run in your PC. Once you do that, you should be able to see the Splunk running on your machine on localhost 8000. So what you have to do next is configure the TCP and HTTP event collectors, which you can do by going in settings and clicking data inputs. So you can see HTTP event collector and TCP event collectors here. What you have to do is click on add new and create those event collectors. So when you click on add new, what you have to done is make sure you put name as mule logs and source type as log4j and is listening on in main index. Similarly for TCP event collector, just enter the port number as 8787 and source type as log4j when you configure that. Once you are done with that, the next step is to upload the JSON file, which is nothing but a configuration of app utilization, which we have pulled from the platform Cloud Hub API. So click on upload, click select file, and you see this app vcode JSON file. Just click on open and click on next. Next. You can choose the index as main. Just click submit. Click start searching. And then create the table view. So with this query, make sure we have all the fields selected. Click on done and click save. Make sure you put the table name as vCourse and click save. So once you're done with that, what we have to do is create another table view. So for that, go back to search and enter the query, which is in the config file search.txt. So just copy this and paste here and click search. Create table view. Make sure you select all the fields. Click save. And save it as chargeback table view. And click save. So I've already done that. The next step is to create a dashboard. So click on the dashboards and create new dashboard. You can name anything, but in readme file, what I have put chargeback demo dashboard. So it already exists, but you can name that as demo dashboard. I've used one. Click on source. Now this source is nothing but the panels which will show up in your dashboard. So what you have to do is open this XML file, copy this and paste it here, click as save, and then create dashboard. So once you're done with creating dashboard, you have configured the dashboard. The next step, what you have to do is go to the Postman and just click send for a couple of the requests, maybe for one ecom and one for mobile. So for mobile API request, you have to make sure that you use this URL, and you have to make sure you pass the X-correlation ID with value as mobile-123 and click send. For ecom API, you have to make sure you have to use this URL and pass the correlation ID as ecom-12345 and click send. Once you do that, if you go to your dashboard you can see that for the 2 requests we have sent, the cost distribution by client for each app. For ecom, 1 request has come in for this app or API, and for mobile it has come for 1 request. But for order ACPI, you can see that there is 1 request for both ecom and mobile. And you can see the cost distribution based on the model we have explained earlier. The second visual, you can also see the request count distribution by client for each app. So basically you can see 1 request has come from e-commerce order API and 1 from mobile order, but both of these requests have in turn called the system API, so you can see 1 each here. The final chart shows the cores utilization distribution by app, which is nothing but the allocation of vCores by each app, which also shows up in this visual. So with this, you can easily instrument the chargeback model in our prototype or using our prototype, or even in your app by using these configurations and implementations. I hope this session and demo was really helpful and it was useful enough for you to go and try out with the blog posting and the GitHub repository I have showed you. Thanks all for watching the video, and once again, the limit for this model and capabilities is endless because you can extend that to monetization or any other chargeback model you want. So with that, thank you again. Thanks for watching.